x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so we've learned about matrices. We know how to add them, subtract them, maybe solve some basic matrix equations, and we've learned how to multiply. We've also used our tool of this Desmos online calculator. Again, it's desmos.com/matrix. And we're going to use this matrix idea of multiplying matrices to solve systems of equations. And there are equations that are a little bit intimidating at first, so we're going to break down exactly what we're going to do with these equations. First of all, we have an x, a y, and a z. And here we have a y and a z, and here we have an x and a y and a z. And so that looks intimidating. And if you recall back in Math 1, we learned how to solve these, and we spent some time doing it in Math 2. But we really didn't spend any time outside of Math 2, and like in Math 3 or in AFM, doing any of this. So it's been a while. So I want to lay down the basic rules of solving an equation so that you understand what we're doing. All right? So there's a lot to this. So let's just go step by step. First of all, if I had an equation that says 3 times x equals 18, I'm sure many of you would agree that the easiest way to solve is to divide by 3. And if we divide both sides of the equation by 3, we'll get x is equal to 6, and we are all happy. But there's an issue with matrices. And with matrices, we can add them, we can subtract them, we can multiply them, but we cannot divide a matrix. So instead of dividing a matrix, what we need to do is we need to multiply it by an inverse. And I know I've said this before that we are solving this equation using inverse operations. And so another way of saying inverse is if we have 3x equals 18, instead of dividing each side of the equation by 3, we can multiply by the inverse of 3. And so if I multiply this side of the equation by the inverse of 3, then I would have to multiply this equation, this side of the equation, by the inverse of 3, and then I'm doing the same thing to both sides. And so this is 3 to the negative 1 times 3. 3 to the negative 1 is the same as 1/3. So that's 1/3 times 3 times x equals 3 to the negative 1 is 1/3 times 18. 1/3 and multiplies by 3 to give you 1, so that'll be 1x, or just x. And then 1/3 times 18 is equal to 6. And you'll notice, without division, we ended up with the same answer. Now I know that's all very basic, and you're thinking, what does this have to do with anything? Well, we are going to set this equation up as a system of matrices. And as we set up our system of matrices, we're going to have 3 different matrices we'll be looking for. The first matrix we're looking for is something called the coefficient matrix. And the coefficient matrix is just what it sounds like. It is a matrix of all the coefficients of x, y, and z over here. So the coefficient of x is 5. The coefficient of y, when we don't see a number, we understand that to be 1. So 5, 1, and this would be negative 4. So 5, 1, negative 4. On the next line, we want the coefficient of x, y, and z. Well, there is no x. If there is no x, that means it's 0 times x, so the coefficient is 0. So this is 0, negative 3, negative 6. And then we have negative 1, negative 1, negative 1. Negative 1, 1, 1. And that's called the coefficient matrix. And we're going to take the coefficient matrix and we're going to multiply it by the variable matrix. the variable matrix is the variables that are in the question. The variables that we're using here are x, y, and z. So this is x, that's y, and that's z. And then we have our last matrix. And our last matrix is -4, -21, and -6. And these numbers are called constants, so constant matrix. So the reason this works is because the way matrix multiplication works is when we're multiplying these two matrices, we multiply each row by this column. So 5 times x plus 1 times y plus -4 times z. And if I multiply this first row times this first column, it's going to give me row 1, column 1, which is going to be -4. 5 times x, 5x, 1 times y plus 1y, plus -4 times z, that's -4z, and that's going to be equal to 4. And the same holds true for the second row times this column and the third row times this column. So that's why this works. So we've set up a matrix equation. And in order to solve this, I'm going to assign letters to these matrices. So I'm going to label this matrix A. I'm going to label this over here, this variable matrix, the thing that we don't know, I'm just going to call that matrix X. And when we call a variable a matrix, we're just going to make sure it's a capital X, because it means there's more than one variable in there. And then we're going to call this one matrix B. So I essentially have an equation. Matrix A times matrix X equals matrix B. So matrix A times matrix X equals matrix B. And I'm going to solve an equation, just like we solved the equation before. We can't divide each side by matrix A because we can't divide matrices. So instead what we need to do is multiply by its inverse. So we're going to multiply this A inverse on each side. And A inverse times A essentially cancels out. It actually becomes the identity matrix, which we talked about previously. And so the identity matrix times matrix X gives me matrix X. And so now I need to solve. Well, it just so happens that I have Desmos.com up. And if you've noticed, I put this matrix in for matrix A already, and I already have this matrix in for matrix B. So now we're going to use these buttons. So we're going to put A, and then this is your inverse button. A to the -1, that's your inverse button. So A inverse B. And when we hit enter, we should have solved this system of equations. And the one at the top is going to be X, because X was our first variable here. And then the one in the middle will be Y, and the last one will be Z. And it'll play out in just a second. So I'm going to hit A inverse B. When I hit enter, that's my answer. And so my answer is this matrix is 5, -5, 6. 5, -5, 6. Which means that X equals 5, Y equals -5, and Z is equal to 6.